Yes, I think, yeah. Can you shut down your mic? You shut down your mic. No interference. Yeah, good. Now good. So because the recording could be very clear, so later helpful for you, right? So when I'm asking question, you can on it. Okay. So everyone can see the slide. Okay. So that day I think we did this. What we did last class? We did about type of forces. After type of forces, we talk about what is meant by equilibrium. We talk about equilibrium. So after equilibrium, we did some questions about equilibrium. Okay. So type of forces, the three main forces you need to know is what? Upthrust, viscous force, and another one is what? Upthrust, viscous force, and frictional force. Okay. So upthrust origin because of pressure difference. Viscous force and viscous force friction similarity is what? The opposed movement. What is the difference between viscous force and frictional force? One, viscous force proportional to the speed. Frictional force, nothing to do with speed. Okay. Okay. So what is the condition to be in equilibrium? The net force of the system must be 0. Okay. Net force of the system must be 0. Okay. Now, we talk about the center of gravity. This is the next part of the topic. So, center of gravity. Okay, what is meant by center of gravity? Okay, the third point is the point you need to remember. Center of gravity is a point where the force of gravity can be considered to act. Okay, it's called center of gravity. It's a point where the whole weight, better include the whole weight, the whole weight. Please add the word the whole weight. Okay, the whole weight can be considered to act. Okay, for the book, normally the center of gravity is the geometrical center of the body. So the book, if you hold the book with the one finger, let's say index finger, you hold it, and the point where you can balance the book in the air, that's your center of gravity. Okay, so the book, if you touch it at the center, it will balance. So that means that is the center of gravity. Okay, so these are a lot of shapes here which has a different center of gravity points. Can center of gravity out of the object, or is it must be always in the object? Anyone can on the mic and tell me? The center of gravity, is it will be out of the object or always must be on the object?
It can be outside.
Good, can be out of the object. So like you see the ring here, the ring is center of gravity is out of the object, it's somewhere here. And L-shape objects, the center of gravity a little out of the object. So it could be out of the object. Okay. If the center of gravity is out of the object, that means difficult for you to balance it. Can't balance it. Okay, because the center of gravity physically is out of the object. Okay. So please remember the point. Center of gravity is a point where the whole weight can be considered to act. Okay. Center of gravity is closely linked to stability, right? A car, when a car manufacturer, when they build a car, they try to make the center of gravity as low as possible, so that more stable, difficult to overturn. Okay, Formula 1 cars so low, moving so fast, 300 km/h, but still can never overturns very easily because center of gravity is very low. So center of gravity is linked to stability, of course. Yeah, as I say, center of gravity and stability. Center of gravity of uniform center of gravity, center of geometry. I told you. Center of gravity can be out of the object. Okay. For non-uniform mass, the center of gravity is towards the heavier side. Yes, good. You see here there is a system here. This entire thing has one system. 100 newtons to the left, 150 is to the right. Where do you think the center of gravity most likely to lie? Close to 100 or close to 150?
150.
Yeah, close to 150. So only close to 150 you can balance it. Okay, the center of gravity is towards the heavier side. towards the heavier side. Okay, so that's your point of center of gravity can be changed if you change shape. Okay, so the second diagram tells that center of gravity is just straight down, but when the center of gravity passes the corner of this object here, then the center of gravity will overturn the object. Okay, so the weight will start to overturn the object, and the weight passes the point of pivot. Okay, passes the point of pivot. In this case, is the corner of this object. That's the point where it start to tilt and start to fall down. Okay, same thing goes for the car. When the car makes a turning, and let's say you make a moving up suddenly, if the center of gravity past the pivot of this tire, if this center of gravity lies to the left here, that's the point it start to overturn. Okay, that's why we need to make the car, the basement, as long as possible, as low as possible, so that the center of gravity take a greater angle to pass the pivot, which is the tire, one of the tire. It's all about stability and center of gravity. Okay, now this is important. How do you find a center of gravity of an object? Finding center of gravity. When a pivot, something means we stop the object from falling. Okay, center line with the pivot. Okay, so let's say I give you a cardboard, a non-uniform cardboard to you. I'm asking find the center of gravity of an object. The cardboard is a random shape, like shown here. Random shape. So how do you find the center of gravity here? You see, first what do you do? If the object is, let's say you hanging here in tilted a little and let it go, it will swing and finally come to equilibrium. When it comes to equilibrium, they say the center of gravity is exactly the line of action of the weight. The line of action of the weight will passes through the point of pivot. This is your point of pivot. The point where it's about rotating. So center of gravity will be the weight. The line of action of the weight, it will be passes through the pivot. This is the line of action of the weight. Okay, line of action of the weight. Weight always act towards the center of gravity. So when it comes to equilibrium, we definitely know the center of gravity is just vertically below the pivoting point. Okay, somewhere here. So we can easily find the center of gravity. Then what we do? We put another location. We pivoted another location and get it achieve equilibrium. Then what happened? The center of gravity will be lower than the new pivoted point. Okay, so the first line you draw here, you have to draw a first line on the object. When you use the first pivot, okay, draw the vertical line down, and when you use the second pivot, draw the vertical line down after it achieves equilibrium. The intercepting point is your center of gravity. This is how you find center of gravity. Okay, what is center of gravity? Is the intercepting point of the two vertical line drawn after the object experience equilibrium at a different pivot. Okay, at a different pivot. Okay, so how to find center of gravity? I already explained to you. This is the one full description. Okay, so the one I told you just now. Hang a plumb line. So this is a non-uniform point. So the body was pivoted at one corner. Okay, we want to draw a vertical line. We can't simply draw a vertical line by using a ruler because the object is in equilibrium. We do want it to. So what we do? We use the hang a plumb line. Plumb line means in front of the needle we hang a string with the pendulum. So the string is the guidance to draw the vertical line. Okay, so hang a plumb line, string with the weight hanging from the same suspension point. Remember, the object and the string cannot touch each other. They are separated. Okay, they are separated. Then this lets you mark the vertical line directly below the suspension point after you come to achieve equilibrium. So you get one vertical line. Then what do you do? Drill another hole, different pivot now. Repeat 1 and 2. So again, hang a plumb line, determine the vertical line, and the 2 mark line cross is the center of gravity, or we can say center of mass. Okay, for an object, center of mass and center of gravity is two different quantity actually. but in A levels, they focus to center of gravity. Center of gravity. Center of gravity and center of mass for a body is always same point. With one condition, the gravity is constant throughout that region, throughout the region. So yeah, so question they won't ask about center of mass, they will ask about center of gravity only. So this is how you need to find center of gravity. Can come out in past year 3 marks question. Explain how do you find center of gravity. So this is the description you have to explain. Okay, center of gravity is found by using a plumb line, hanging a plumb line. Use one pivoted point, let the object come to equilibrium, hang a plumb line, trace a vertical line below the pivot, repeat the step 1, 2, 3 for a different pivot. The intercepting point is your center of gravity. Okay. Any questions so far? Okay. So anything you like to ask, you can WhatsApp me. I don't want to use the Teams chatting. Okay. Any questions? I just my side I have my phone. Okay. So now the problem starts. How if force are not acting at the common point? What will happen? An object, the forces never act in the common point. For example, like this. You have a system, the force is acting at a different point. Okay. So what will happen to this object? It will start to turning it. You're going to turn about the pivot. Okay. So when this happens, when the force is not acting at the common point. Now we are entering the another last part of this topic, turning effect. Okay. So turning effect of forces. The moment of force about a point is the product of force and perpendicular distance r from the line of action force. It's called moment of forces. Okay, you have a spanner, you want to turn the nut, so you must create a turning effect. So how to give a turning effect? You apply a force F1 or F2, but which gives you easiest to turn the nut? Of course, F1, right?
Yes.
The one further away from the pivot. Okay, so the quantity which makes the nut to turn around is called moment of force. It's called moment of force. Okay, it's called moment of force. So it's moment of force. So what is moment of force means? Moment of force, moment is what? This is not momentum. This is moment. This is different. Moment of force is the force times perpendicular distance from the pivot. Perpendicular distance. This is your pivot, and this is the turning point. The perpendicular distance. This R1. Okay. So moment of force is the force and perpendicular distance r from the line of action of the force to the point. Line of action of the force. Line of action means you draw a straight line. Line of action of the force. Perpendicular distance. Perpendicular distance between the pivot and the line of action of the force. So in this case, the moment caused by F1 is what? F1 times R1. Okay, that's the moment caused by F1. What is the moment caused by F2? F2, same thing. So moment caused by F2 is F2 times the perpendicular distance. Perpendicular distance between the line of action of the F2. Okay. And I think should be R2. So here also should be R2. Must be R2. So R2. So moment of F2 is actually F times R2. Okay, this is moment of force. What is the unit for moment? Anyone? What is the unit for moment? Newton and meter. So it's Newton meter. Okay, so this is the moment. Okay, so when a car engine, when there is a car engine, the car engine, every nut on the car engine, you can't tighten it with a high tightness or low tightness. It needs a specific tightness. Okay, so every nut on the car engine in the car manual book will state for this particular nut this much of moment, Newton meter of torque need to be applied. Newton meter, they'll tell you how much of moment need to be applied. Is it 80 Newton meter or something? So if the nut is 80 Newton meter, when they use the spanner, they must apply a certain force so that the force times the perpendicular distance is about 80 Newton meter. Okay, if more than that, you're going to spoil the structure of the engine. Too tight or less tight, it's going to damage the engine. Okay, so that's a turning effect. Okay, moment. How much of moment causes turning effect? Okay, it is Newton meter. Okay, so which wrench would you choose to screw an stubborn bolt? A longer one or shorter one? Of course, the longer one. Why? What's the answer? Greater moment. Greater moment of force. Why longer one, greater moment of force? Of course, greater perpendicular distance. How do you rise moment? Two ways. Rise the force or rise the perpendicular distance. But we, as a human, we want to be quite lazy. We don't want to apply a little force, but we need a greater moment. It is the longer spanner, a greater perpendicular distance. Okay. So you look at this diagram. Two people are pushing the door. So F2 and F1. Okay. I think who will? You see, a small kid can push the door, and of course, the guy who was stronger can push the door. But F2 greater, F1 greater, technically. So F2 is going to be greater, right? Because shorter perpendicular distance from the pivot. Because the person and the girl must exert the same amount of moment, let's say, then F2 have to be greater. Okay. So short perpendicular distance means F need to compensate, must get bigger to give the same moment. Okay. So this diagram, what it does. Okay, this diagram tells that, let's say the force applied in this spanner, this is the spanner, and the force is applied not perpendicular, the force is applied diagonally, F. Okay, diagonally F. So how do you find moment of F in this case? How do you find moment caused by this F in this case? Because the pivot is here, but the force is a little diagonal. Okay, it's little diagonal. If the pivot is here, if the force is like perpendicular, that's okay. Moment caused by this force is force times this R. Okay, force times R. The force and R must be perpendicular. But if the force is diagonal, then what do you have to do? You must find this angle. Okay, we want to make use of this R, right? You want to make this R. You find the vertical component of this force. Okay, you must take this component. So the moment caused by this system, the new moment is what? Is the, of course, times R, but the force you must use the component which perpendicular to the perpendicular distance. So that force. So in this case will be how much? F sine theta or F cos theta? As theta here. So F goes up, you open the angle, theta get bigger. So use sine or cos. Open, use sine. So F sine theta. So F sine theta to be used. This is the moment. Okay, this is the moment. Okay, so that's what's shown in this diagram. So F is diagonal. So the vertical component is F sine psi. So this is your R. So moment caused by this F is what? So F sine alpha times R. Okay, this to multiply. It's the moment. Okay. Or there is another one way. Another one way is don't resolve the force. The force you need to resolve. Okay. This force here, F, you just prolong it. It's the line of action of the force. Okay, this is the pivot. Okay. So draw a straight line, perpendicular line to the pivot, 90 degrees. This is the perpendicular distance. So the moment caused by the F, by this F, you can written as F times D also. Okay. So in this case, the moment caused by F could be F times D, or could be what? F sine psi multiplied by what? R. So both accepted. Both will give you the same answer. Okay. Either you resolve the force, make it perpendicular to the distance, or you don't want to resolve the force, just extend the force longer from the pivot to that line of action of the force. You draw a straight line, 90 degrees. You must use that perpendicular distance. Okay, two ways. Which one to be easy to use? Depend. Okay, most of the time, if angle provided, you have to use the second one, this f sine alpha times r. If angle not provided, this perpendicular distance is provided, then you have to use the first one. Okay, both needed. Okay, depend to the availability of the information. Okay, so this is how to find moment. Okay, so this is a playground. So we need to turn that thing. So force is applied. The force applied by the person here is F times perpendicular distance R, Fr. Okay, but if the person apply a force diagonally like this, the moment created by that person should be F sine theta times R. Okay, so you must make the force perpendicular to the distance. So what is moment? Is the product of line of action of the force and the perpendicular distance from the pivot. Okay. Or what you can do, you don't want to resolve this force, you just prolong this line. You just prolong this line straight. Which distance you take? This is the pivot. This is the pivot. You have to draw another line like this. This D. You can use this perpendicular distance, 90 degrees. So the moment caused by this F can be written as F times D also. Okay, it could be X times D. Okay, or can be what? Or can be, you resolve it. Resolve it can be F sine theta times the perpendicular distance R. So both can. Okay, both accepted. Okay, any questions so far? This study effect. Okay, let's move on. So moment, shorter one, larger one, more larger. So you can see sometimes if you accompany your father, go to the maybe mechanical the car shop. Sometimes some nuts in the car is quite tight. They have to use the air gun, but if they don't have, they use the spanner. But if the spanner does not enough to create the torque, they put another bar, what do you call, a cylindrical iron bar. They pull it at the side here, just to sake of increasing the particular distance, so that more moment, more Newton meter to turn the nut. Maybe the nut is quite rusty or need a big torque. Okay. Okay. So moment, another practical name used for moment in the everyday life. When you go to the car shop, they never call it moment. They call it torque. Okay, torque, T-O-R-Q-U-E, torque. So they will say, okay, how much of torque needed to turn this nut? How much of torque needed to loosen the nut? So torque, practical term lah. But moment is another name. Moment of force. Moment of force, torque. Torque, I can say is like a resultant moment. Resultant moment. Torque. Moment, resultant moment. Both unit is Newton meter. Okay. Can now you tell me, torque or moment, vector quantity or scalar quantity?
Vector.
It's a vector quantity. Moment as a torque or resultant moment as a direction. How many directions do it as? Only two direction lah. Either clockwise moment or anti-clockwise moment. Okay. So clockwise moment, you take it positive, means anti-clockwise moment, you must take it as negative. Like momentum. To the right positive, to the left negative. So moment is a vector quantity as a direction. Clockwise, anti-clockwise. Okay. Okay, very fast. Come on, tell me. A, B, C, D, E, 5 diagram. Which gives the greatest, which gives the smallest moment? You can put it in WhatsApp. Which gives the smallest moment?
C.
Oh, yeah, of course, C. What is the moment of C?
0.
0. So when you apply a force pass through the pivot, no turning effect. So of course, C is the lowest line. Okay, the others we can calculate later. Okay. Okay, now your turn. So look at this diagram. So a system pivoted at this corner on the left. 3 forces acting. 4 Newton, 5 Newton, 6 Newton is acting. Calculate the sum of moment of the force 0.6 meter rod above the nail at the left. 3 forces acting on the rod as shown in the diagram. Calculate the sum of moment. Okay. So how do you calculate the moment? First, they want what moment? They want resultant moment. They want sum of the moment. Sum means what? The net moment lah. Net moment. Okay. First, you need to identify the moment. Is it clockwise or anti-clockwise? Okay. So how to check the moment going to turn the thing clockwise or anti-clockwise? So you check like this. This is your pivot. Okay. 4 Newton. When you apply force 4 Newton here, this moment caused by 4 Newton is going to turn this rod anti-clockwise or clockwise? 4 Newton. See, you have a rod, you apply just, yeah, it will be anti-clockwise, right? It will be anti-clockwise. How do you know this is going to be anti-clockwise? The easy way is you just draw the arrow, is 4 Newton, okay? Go towards the pivot. Go towards the pivot. Go around the pivot. Go around the pivot. Sorry. Where's your pivot? Pivot is here. So you just go around the pivot. Just go around the pivot and come back here. Go around the pivot. So you go around the pivot. You are moving this way. Okay. So the movement caused by 4 Newton is which direction? This is which the movement is which direction? It's a create a moment of anti-clockwise movement. This is one way to find it. What do you do? Go around the pivot. Please don't go around this way. Okay, this way like a bigger angle, you know. You go around this pivot. You go the smaller angle, those nearest. I think this is smaller angle. Go around this angle, smaller angle. This is a bigger angle, more than 180. You have to go around to the nearest angle. So this is anti-clockwise. 6 Newton. Moment is clockwise, anti-clockwise. 6 Newton. So 6 Newton acting down. Go around the pivot. Where's the pivot? So the pivot, go around the pivot. So this is a go around the pivot. So which direction is this? Which direction is this? This is your clockwise movement. So this is a clockwise movement. Okay, clockwise movement. 5 Newton. What is the moment caused by 5 Newton? This is easy. 5 Newton line of action just pass through the pivot one. So 5 Newton moment is of course 0 0, no perpendicular distance. The force line of action of the force pass through the pivot. Okay, so my advice: when you see any system with forces, they're asking calculate the moment. First thing you must do is identify all the forces acting. Second thing you must do is find is it a clockwise moment or anti-clockwise moment. Go around the pivot. Okay, go around the pivot by using a smaller angle. Okay, not a bigger angle. Like 6 Newton here. What I mean by smaller angle, bigger angle. Okay, like 6 Newton here. You don't go around here and go around the pivot. Okay, if you go this round, you make what angle? You get 270. It's a big angle. 6 Newton, you go around this way to around the pivot because 90 degrees only, small angle. So follow the small angle. So now check the moment. The moment, the clockwise moment. Sorry, the counterclockwise. CCW is counterclockwise. counterclockwise moment, is caused by the 4 Newton. So how do you find moment of 4 Newton? Perpendicular distance is 0.3, but force is diagonal. We have to resolve it vertical. We need to get a vertical component because we want to make use of the 3. So 4 resolved vertically is 4 sine 30. You open the 30, right? 4 sine 30 times 0.3. So moment caused by 4 Newton is 0.6 Newton meter. 0.6 Newton meter. This is the clockwise moment. Okay. So, sorry, counterclockwise moment. Counterclockwise moment, according to this working, we assume like positive. Counterclockwise, we take it as positive. Clockwise, we take it as negative. Okay. Choice is yours. You want to go the other way around? Can. It's conventional. Like momentum. To the right, not always. We will take it as positive. If any student take moment to the right as negative, is it wrong? It's correct. It's conventional one. It's up to you. But we stick with one line. Counterclockwise like positive, counterclockwise is negative. Okay, next. The moment caused by 6 Newton is clockwise. So 6 times. Perpendicular distance is 0.6. So 3.6 Newton meter. So therefore, the sum of the moment is both need to be subtracted. Okay. The counterclockwise minus the clockwise. So finally, it's found to be 3 Newton meter. So 3 Newton meter, finally what? 3 Newton meter clockwise. Okay, negative shows clockwise. So the bar going to turn clockwise direction with the moment of 3 Newton meter. Okay, so 5 Newton does not because no perpendicular distance. So any question for this example? So what you must do when you're dealing with moment? First, identify all the forces first, which direction is acting. Second, decide first, is it a clockwise moment or anti-clockwise moment? Okay, go around the pivot. Third, the resultant moment is the total clockwise moment minus the total anti-clockwise moment. You have to minus them. Okay.
Teacher.
Yep.
Should the 0.6, wait, which one should be negative value? Like going left, right?
So according to this working, we take clockwise moment as negative.
Clockwise moment.
So in this case, 6 Newton is a clockwise moment. So 6 Newton, we take it as negative moment. This is negative moment. Okay. So clockwise moment, we take it as negative. Okay. Anti-clockwise moment, we take it as positive. Okay. Any other questions? Anyone? Before we go to the, yeah.
That means that it can be changed, or we can determine how it is.
Choice is yours. We fix it. I fix in this class now. You take clockwise as negative, anti-clockwise as positive. You like to use the other way around, also can. Okay, but we stick with this law. We don't want any confusion. We just fix this, stick with this entire class. To the clockwise is take negative moment, anti-clockwise as a positive moment. Okay.
Okay.
Yeah, so we go to the next question. Now you're going to give a try. Okay, so this is the next system. 1 minute for you. Come on, give a try. Calculate the sum of moment of forces on the 0.6 meter rod above the nail at the left. The nail is here. This is a pivot. Identify this is a pivot. Okay, this is a pivot. Okay, about the left. 3 forces are acting on the rod as shown in the diagram. Calculate the sum of moment. First, identify the moment. Is it a clockwise moment or anti-clockwise moment? That is the problem. 4 Newton. This is a pivot. 4 Newton. 4 Newton clockwise moment or anti-clockwise moment? It's going to create a clockwise moment or anti-clockwise moment. 4 Newton. So go around the pivot. So this is the 4 Newton acting. Where's the pivot? Pivot is here. So we go around the pivot. So go around pivot. Yes, which direction it takes? It takes this direction. So 4 Newton is a counterclockwise lah, counterclockwise. Okay. So this moment caused by 4, we take it as positive, positive moment. Counterclockwise, we take it as positive. 2 Newton. What type of moment it give? From here, go around the pivot. Go around the pivot here. So you take this direction. So moment caused by 2 Newton, clockwise, anti-clockwise. This is which direction? It's a clockwise moment. So 2 Newton is a clockwise moment. 5 Newton. 5 Newton also go around the pivot. Go this way. So also clockwise. So this is a clockwise moment. 3 Newton, no need to do because just acting on the pivot, so it does not give any turning effect. Okay, find the resultant moment. Resultant moment means total clockwise, counterclockwise moment minus the total clockwise moment. Okay, so CCW, total counterclockwise moment, total minus the total clockwise moment. Okay, total should give you the resultant moment in terms of Newton meter. Anyone got the answer? 1 minute. Give a try. Okay, put it in the WhatsApp. Okay, so anyone got the answer? How many Newton meter? Finally, is it going to be clockwise moment or anti-clockwise moment? Okay, so some of you said 1.5 Newton meter, negative 1.5 Newton meter. So negative 1.5 Newton meter. Also got negative 1.5.
Negative 1. No, negative 0.
Negative 1.5, negative 0.5. So negative means looks like it's moving clockwise moment. It's turning clockwise. Let's see. So the moment caused by positive 4 Newton is 0.6 Newton meter. The moment caused by negative is, you have to resolve the force. So you see the working, negative 0.3 times 5, 0.3 times 5, okay, moment caused by 5. 0.6 times 2 sine 30, why sine 30? Because 30 degrees here, you need to get the vertical component one. So 30 is here, so you open the 30, so you sine 2 sine 30 times 0.6. Now you get the total clockwise moment 2.1. So finally you got negative 1.5 Newton meter. So finally the system going to rotate clockwise or anti-clockwise? You're going to rotate clockwise. So it's a clockwise direction. Okay, it's going to rotate clockwise with the 1.5 Newton meter of torque. Okay, that's why this is the turning effect. Okay, the 5 and 2 Newton try to turn it clockwise, but 4 is opposing it. But finally, 1.5 Newton meter was achieved, so it will turn clockwise. 3 Newton does not involve because no moment given by 3 Newton. What's the reason? Because 3 Newton the line of action of the 3 Newton is passed through the pivot. So therefore, no moment. Okay. So the question is going to be more trickier now. You need to understand these two first. Any questions from here? All looks clear. So when you do the moment question, what do you have first? You have to do identify all the forces, identify the pivot. Next, check them. Very important. Is it a clockwise moment or anti-clockwise moment first? Go around the pivot. Identify that. If you make a mistake there, entire thing gone. Okay. So go around the pivot to check is it clockwise, anti-clockwise. Okay. Let's go another one. Okay, this one. 2 minutes for you. Give me the final answer on the WhatsApp. Sorry, let me check what answer. No. Yeah, don't have answer. This one don't have answer. You need working. The slide also you don't have answer, so you need working. Get the working, come on. Calculate the sum of moment of force on the 3-meter rod that is pivoted at B. So this is your pivot, and this is your pivot. So the one sum, counter-clockwise movement, the total must minus with the clockwise movement, total. Then you can get the answer. How many Newton meter? You must check what first. Check all the forces. Do they give clockwise moment or anti-clockwise moment first? That's important. Your pivot at B. 90 give clockwise, anti-clockwise. 90. Go around the pivot. 90, just go around the pivot. So this is clockwise movement. 80. 80 go around the pivot. 80 also clockwise movement. 70. 70 no movement, right? Because pass through pivot, right? 60, 50. 50 any moment. 50 also no moment because pass through the pivot, right? This also don't involve. 60, go down, go around the pivot, go around the pivot, is the around the pivot. So which direction is this? This is anti-clockwise movement. So this is counterclockwise. Okay. Yes. This is how we visualize it. So put your total counterclockwise. How many counterclockwise appears here? Only the 60 Newton. Moment caused by 60 Newton is counterclockwise. How many clockwise moment are there? There are 2 clockwise moment. So you need to add them, minus, then you get the final answer. Okay, class, come on, give me the final answer. The forces you need to resolve, because the force must be perpendicular to the distance. Okay. So the 60 Newton, the 19, 80 Newton, all you find the vertical component. You have to find this vertical component. How much? Then you can use the perpendicular distance. So the answer will be in form of L, because L not given. Oh, L given, yeah, 3 meters, sorry. L is 3 meter, right? Also final answer. Okay, I'm receiving answers. Answers, oh, 2 different answers. So one said, okay, many saying is 156, 155, 156. One of you said 16. Check back, any mistake? Is it 16 or 150 something? 156 or 16? Oh, many giving 156. 156, huh? So I think, is it 156? Okay, let's see. So counterclockwise movement is how much? Counterclockwise movement, counterclockwise. Yeah, counterclockwise movement is what? 60 times half L. Half L is how much? L is 3 meter. 3 meter minus clockwise moment. 90 is what? 90 we resolve vertically, so we're going to be 90. You open the 40 degrees, so it's become sine 40. Then Sine 40 times how many L? 3 meter. 3 meter. I have to make a closed triangle, closed bracket, and plus with moment caused by the other one is what? Moment caused by the other one is 80. 80 clockwise moment. 80 sine again, right? Sine 37. Okay, 37. 37 times how much? L is of L. So of L, so 1.5. Okay, so this is your numbers, right? This is how your numbers could be. You get negative 156. 156. Negative 156. Majority getting 156. So I take that answer. Negative 156 Newton meter. So it's negative. So negative means finally you're going to turn clockwise, anti-clockwise. You're going to turn clockwise direction. Clockwise direction is the winner. Okay. So this is how you have to do. Okay. So question going to be another one, last one for today. Okay. Okay, come on, you try. Hope everyone get the same answer. Give me the answer in the WhatsApp again. Hope everyone get the same answer. Okay, once you got, put it and send to the WhatsApp. First identify the pivot, then check which one is clockwise moment, which one is anti-clockwise moment first. A small mistake in that is going to destroy entire working. Okay. Calculate the moment of force 5.5 that is pivoted at A. So there's a pivot. Mark the pivot first. This is your pivot. This is the pivot. That means this force is 60 is like not going to involve in calculation of moment. The other three. This 50 give a clockwise, anti-clockwise moment. Go around the pivot. Go around the pivot this way. So this is a what moment? This is a counterclockwise. It's a counterclockwise. 80 also counterclockwise. 70 going to be clockwise. Okay, so find the net moment. So resultant moment. As usual, counterclockwise moment. Total minus the clockwise moment. Total will give you the resultant moment. So any answer? Anyone? How many Newton meter? Counterclockwise moment 50 times. So L is 5.5. So 50 times 0.2 L, right? 0.2 L. So 50 times 0.2 L. I just put L first. Okay. Plus with. Oh, I'm receiving answers. So next is what? 80. 80 what? 80 sine 30, right? 80 sine 30. Sine 30 times it, because sine 30 will resolve up, times it, the entire L. L, that's your counterclockwise moment, minus with 70 times this distance. This distance is 0.8 L, so 0.8 L. Okay, the L all you substitute at 5.5. I'm getting the answer now. The answer is all 33. 33. Okay, good. So all of you got 33. 33, 33, 33, 44. Or some of you got 44. 44 or 33. Majority is saying 33. Please check the working, those who got other answers, 44. So I follow the majority. So negative 33 as the answer. Okay, so negative shows is finally going to turn clockwise movement. Going to turn clockwise movement. Yes, good. Okay. So this is a turning effect movement. Okay, so still receiving answers, still 33. So I declare 33 is the answer. Okay, so those who get other answers, please check your working. So the mistake, I think most probably your clockwise, anti-clockwise direction, check carefully. 60 won't involve because it's act at the pivot. Okay, because so we are end of the lesson for today. We just halfway of discussing moment. Okay, so next class will be talk about something called talk of a couple. Okay, talk of a couple. Yeah. So okay, the tutorial one, I already marked the tutorial one already in the times. You can check. I put the mark scheme also under the times, under the tutorial one. The answer sheet mark scheme for the tutorial one. Okay. I think next week Monday you will have tutorial 2, second tutorial. It consists of kinematics and dynamics. Okay, a third and the fourth topic. Okay, be prepared. Again, I'm going to give you like maybe like 1 hour for you to do. Then after that, 15 minutes for you to, within 2 hours, I want you to upload in the times in a PDF form. Okay, try to learn changing JPEG to PDF because most probably your coming semester 1 examination, see how's the condition. If you're unable to go back to college, your trial exam most probably will be online. So if it's an online exam, you must post your answers in a PDF format. Okay, so try to learn how to convert your JPEG to PDF. There are a lot of apps there, okay, to convert it. So convert and put it in the times. Okay, the tutorial marks I'll be using to check, to award you the what you call forecast results when you apply for universities. Forecast results. So try to take it seriously. Give a try. Okay, just try your best. Because your forecast will be forecast many times. Let's say you did very badly in your tutorial. I give a very poor forecast like a D, let's say. But the semester exam you got an A. Your forecast will pull up to A. Okay. So the important is you must go for an upward trend. Okay, upward trend. You're just improving up. Then your forecast will improve. Okay. So any question so far?
So
Yeah.
that means that what is it? The tutorial we do it on the spot 1 hour or we do it later?
You do it within that duration, 1 hour, and you upload it like 2 hours. I'll put like in 2 hours time. Like I treat it like a test also lah.
It's next week.
Next week Monday.
Okay.
Okay, kinematics and dynamics. Maybe 2 or 3 questions, structure questions. Maybe I include. Okay. Okay. Any other questions? Anyone? No questions, Okay, good. So see you tomorrow.